Bismillahirrahmanirrahim. Assalamu alaikum, students. Today we are going to solve together another problem. Let me write the problem. Our problem says an alpha particle what is alpha particle? The nucleus of a helium atom travels along the inside of a straight hollow tube two-meter long, write it precisely, 2-meter long, which forms part of a particle accelerator. Then part A of the problem says if one assumes uniform acceleration what is the acceleration of the particle if it enters at a speed of 1.0 into 10 raised power 4. Write it clearly. 10 raised power 4 meter per second and leaves at 5.0 into 10 raised power 6 meter per second. Second part of the problem, part B says how long is it in the tube? This is today's problem. Let me check it. An alpha particle, the nucleus of a helium atom, travels along the inside of a straight hollow tube, 2-meter long, which forms part of a particle accelerator. Part A says if one assumes Uniform acceleration. What is the acceleration of the particle if it enters at a speed of 1 into 10 raised power 4 meter per second and leaves at 5 into 10 raised power 6 meter per second? Part B says how long is it in the tube? So we have a particle called alpha particle. You know it is helium nucleus. It contains two protons and 2 neutrons. So it is helium nucleus. Now this particle travels inside the straight hollow tube, which is 2 meters in length. And that tube is actually a part of some particle accelerator. You know, we have accelerators in which we increase the speed of particles, which are required in different experiments or different purposes. A question is saying when it enters the tube, it has some speed. When it leaves the tube, it has larger speed. We are supposed to assume its acceleration uniform, and we are asked to find the acceleration and the time it stays in the tube. So this is the motion in a straight line with constant acceleration case. So let us move to the solution. You know the equations of motion with constant acceleration. You know the idea of constant acceleration. Acceleration is the rate of change of velocity. If the velocity changes by equal amounts in equal intervals of time, we say the acceleration is constant. And for such a motion in one dimension, we're talking of one dimension motion in a straight line, we have a set of equations called equations of motion. Let me write them with some other color. One is V is equal to V naught plus AT. Second is X is equal to X naught plus V naught T plus half AT square. Third is V square is V naught square plus 2A X minus X naught. And I can write two more. X is X naught plus half V naught plus V T. And there is one more. X is X naught plus Vt minus half AT square. Let me check them. V is V naught plus AT. X is X naught plus V naught T plus half AT square. Then we have V square is V naught square plus 2AX minus X naught. X is equal to X naught plus half V naught plus V times T. Then I have X is X naught plus Vt minus half AT square. Actually, as you know, these two are the main ones. First one gives us velocity at any time. Second gives us position at any time. So you know the symbols. V naught is velocity at t is equal to 0. V is velocity at time t. A is acceleration, which is assumed constant. These equations are valid only for constant or uniform acceleration. T is time. X naught is position at t equal to 0. X is position at time t. So we have x axis as a straight line along which motion is taking place. So first two ones are the main equations, then these three are obtained from these first two. When you eliminate time between first and second, let me name it first, second, third, fourth, and 5. So if you eliminate time between first and second, you get third. If you eliminate acceleration between first and second, you get fourth. And if you eliminate initial velocity V naught between first and second, you get 5. So there is no initial velocity in 5. There is no acceleration in 4. There is no time in 3. So all 5 we can use as per our convenience in case of motion in a straight line with constant acceleration, right? So let us move to our problem. So suppose this is our tube. This is our tube. And this is our alpha particle entering it, here leaving it. What is this distance? Length of the tube is 2 meters, as is given. And the alpha particle enters with velocity, which will become our initial velocity. So its initial velocity V naught is it is 1.0 into 10 raised power 4 meter per second. And when it reaches the other end of the tube, the velocity is final velocity attained by it in this accelerating tube, which is 5 into 10 raised power 6 meter per second, right? Let me check. Initial velocity is 1 into 10 raised power 4. Final is 5 into 10 raised power 6 meter per second. So here its velocity is, let me use some other color. Here its velocity is 5 into 10 raised power 6 meter per second. Here when it enters the tube, its velocity is initial velocity, which is 1 into 10 raised power 4 meter per second, right? This is the information given, and it is assumed, given in the question, that we need to assume that A is constant. When we need A is, assume A is constant, that means we can make use of these equations. And this straight line along which motion is taking place, we label it as x-axis. This is our x-axis. We need to specify now. So we take our x-axis parallel to the tube. Its positive direction we need to specify. What we do, we take its positive direction as the direction in which particle is moving. So this is my positive direction. Positive x-axis is this way, to the right. This is your choice, but you have to interpret your results accordingly. So we are taking here x-axis parallel to the tube and positive direction in which the particle is moving. And here we take origin of the x-axis. If I take origin at one end of the tube, that means my initial position coordinate is 0. At origin, coordinate is 0. So my x naught is 0. And the position attained at other end is x. So x is my then 2 meters. So one end is I am taking origin. So my x naught is 0, and other end coordinate will be plus 2 meter because the length of the tube is 2 meter. So we are given V naught. We are given V naught, V, X. This is given, right? What we are supposed to find, we're supposed to find A in part A, acceleration, and T in part B. So let us move to part A of the solution to find A. You can see which equation we can use to find A. We will simply use this third one, this equation. If you solve for A in equation third, let me use some other color. If you solve for A in equation third, what you get? You get A is V square minus V naught square over 2x Actually, it will be V naught square minus V square minus V naught square is 2AX minus X naught. X naught we are taking 0. So A will be V naught square, V square minus V naught square over 2X. V square minus V naught square over 2X. Now V is given, V naught is given, and X is given. So you can see how we are using the equations. We are seeing what we have, what we have to find. Since we have V naught, V and X, so we can solve from this equation 3A. So let us put the numbers. I think I use this color. Let me put the numbers. This is light. This one. V square. What is V? 5 into 10 raised power 6 meter per second square. Then minus V naught 1.0. Then write just 5 for 5.0. 1 into 10 raised power 4 meter per second square over 2x. Our x is 2 meter. 2 meter. Let me check. My V is 5.0 into 10 raised by 6 meter per second. Then I am squaring it. Minus my V naught is 1.0 into 10 raised by 4 meter per second. Then I square it. Divided by 2x. X is my 2 meter tube length. So when I put it, you will get plus. It has a meaning. Plus 6.3 into 10 raised power 12 meter per second square. This is the answer of part A. Let me encircle it. Plus 6.3 into 10 raised power 12 meter per second square. As always, check this calculation at home. Check it at home. And enjoy the calculation. So we have obtained the acceleration. Part A we have solved. This was our part A of the problem. This plus sign has meaning. That means the acceleration is, velocity is changing per second by 6.3 into 10 raised by 12 meter per second. Plus means that acceleration is taking place in this direction. That means when particle is going from x naught to x, it is accelerating because this positive direction we have taken as the direction of motion of the particle. Now let us go to the part B of the problem, in which we have to find time. Now if you see the fourth equation, that is this. Here, initial velocity is given, V is given, our x naught is 0, x we know, so we can solve for t. So here we use 3. Now I will use 4. Using 4. I can write t is 2x over V naught plus V. You can check. X naught is 0. So you will have 2x by V naught plus V is t. We have written that 2x by V naught plus V is t. So let us put the numbers. X naught is 0. I will change the color of my pen. 2 times 2.0 meter over V naught is 1 into 10 raised power 4 meter per second. Then plus V is 5 into 10 raised power 6 meter per second. When you make the calculation, you will get 8.0 into 10 raised power minus 7 seconds, or you can write it 0.80 microsecond. So this is our answer for time. Let me encircle it. Let me check it. 2 into 2 over 1 into 10 raised power 4 meter per second is my V naught, plus 5 into 10 raised power 6 meter per second is my V. So it is 8 into 10 raised power minus 7 second, which is 0.80 microsecond. Remember, 1 microsecond is 10 raised power minus 6 second, right? So as always, you have to check it at home. You have to check the calculation whether this number is wrong or right. You can see this number, this time is very small. So this alpha particle is getting huge acceleration in this tube in very small time, 0.8 microsecond, right? So this is all for today. I hope you got the idea and you got this problem, how we make use of these equations, right? So this is all for today. Go through all the problems and you can make a notebook out of it. It will be helpful for you. And don't forget to like, share, and subscribe my channel. You can comment in the comment box. Thank you. God bless you. Assalamu alaikum.